welcome to the podcast. This is Mr. White.
And Mr. Sadler.
And today we're going to talk all about friction. I love this investigation, titled The Mew of the Shoe.
It's sort of, this investigate's nice because you can take a slippery shoe versus a gym shoe, and you can see why athletes wear gym shoes too.
Right. Why it's so important, and we can talk about why it's so important for the floor of a gym to be clean all the time, as opposed to
BBs on it or something.
Yeah, as opposed to something else. So friction. What do we think friction is, Mr. Sadler?
Friction is a force that works against something moving.
Okay, it's a force. It can it works against. I'm a little leery of the word work, but works against motion.
Mm-hmm. So if I hit a cue ball, it slows down because of friction. The reason that I'm able to run, if there was no friction, I wouldn't be able to run.
So it's a force that can help or hurt motion, actually, because without it, nothing would happen.
Right.
But too much of it,
and nothing happens.
Right. So it can work against a moving object, and it can also prevent the motion of a static object. Is that true?
Correct.
Sure. And so I think probably one of the easiest things to do is to go to a free body diagram. So this can be any object. And let's say that we are applying a force on that object to the right. So I'm going to say this is an applied force, F sub A. This could be a push or a pull. It could be a string or a rope applying some tension. It could be a lot of things. And of course, we know that the object has some weight directed down.
And a normal force.
And it has some normal force acting up. And the thing that is preventing the motion is the frictional force. So we go ahead and define that with a lowercase f. Now, if we have a moving object, then we get really specific, and we call this kinetic friction.
Oh, kinetic means moving.
Yeah.
Okay.
So this is, or moving friction, is what we're talking about here. If we were to redraw our picture for a static object, or for a stationary object, we still, by the way, have the normal force and weight, not a problem, and we can still have this applied force. But now friction is preventing the motion, so we would call this static friction, right? So this is static friction prevents motion. In order to make the object move, in order to change the motion, the applied force must overcome the static frictional force, right? And at that moment in time, when FA is larger than F static, then we have an acceleration and we start applying Newton's second law. Okay. Some things to know about the two. The static frictional force is always greater than the kinetic frictional force.
Well, we sort of know that, right? Because once you get something moving, it's easier to keep it moving than sometimes to get it to move.
That is correct. So if you can overcome this static friction, the kinetic friction is an easier force to deal with. This whole idea of friction, it doesn't matter what kind of friction we're talking about, it's equal to this Greek letter mu, hence the mu of the shoe, times the normal force, which in every case we have seen has been exactly equal but opposite to the weight of the object. Okay, now that's not always true, but for all intents and purposes for us, that's going to be true. So this is the Greek letter mu, and it relates to the coefficient of friction. This is a unitless quantity.
It's probably different for different items.
And it's dependent on the surface. So the material maybe is a better term. So for example, your car's tire is made of rubber, and the asphalt is made of this gravel tar substance. The coefficient of friction between your car's tire and the asphalt is big, lending itself to a really large frictional force.
Well, that's good. I want to stay on the road.
Right. Now, when the weather turns poor and we start to get ice or sleet or snow, there's this layer of slushy mess between the tire and the asphalt, and as a result, the coefficient of friction goes way down. So the normal force of the car and the road hasn't changed because the car's weight is exactly the same. You know there's less friction because you start slipping and sliding. Well, that's due to this low mu value. Steel on ice, like an ice skate,
Right.
has a very low coefficient of friction. Rubber on anything. Wood generally has a pretty high coefficient of friction. You know that things have a high coefficient of friction because when two objects rub past each other, slide past each other, they get hot. They heat up really quickly. Surface area is a part of this. Material is a part of this. All of these factors come into play. Low coefficient of friction, these when they slide past each other, they don't heat up. So we haven't gotten to energy yet, but we're not losing energy in the form of heat with a low friction surface. Does that make sense?
Sure. A lot of the manufactured products that we have, plastics and stuff like that, probably have a low coefficient of friction because they are able to slide past one another.
Right, and so engine parts, they're lubricated with oil. They have a low coefficient of friction, even when they get hot. Like steel, is at room temperature is a really low coefficient of friction. But as they rub past each other hundreds of times per minute, they get hot, and then the coefficient of friction actually raises. So the oil in your car's engine actually helps with that. So there are some values that you can find in textbooks. Your book mentions a few of them on page 214. We use the Greek letter mu because, frankly, we ran out of English letters in our alphabet. So we went to the Greek alphabet, and a lot of this stuff was known about, before English was invented, actually, when Greek was the predominant language. So I suppose I always like to talk about this when we do friction. I like to talk about Teflon. What is Teflon, Mr. Sadler?
It's another manufactured product. Teflon tape they use in pipe, or Teflon, I've seen like Teflon that they use between parts to keep them from rubbing.
So
it must have a low coefficient of friction.
it's got a low mu value, therefore low friction. And I first learned about Teflon when I was a college student, and I was cooking on the cheapest cookware that I could possibly
The old
buy.
Teflon cookware.
Yeah, so a lot of this shows up in cookware. It's the no-stick
Right.
surface, and so it makes washing the pots and pans a lot easier after you're done using them. And in college, I burned everything, so it made cleaning up a lot easier for me. And then I learned how does the no-stick substance
Stick to the pan.
stick to the pan. This bothered me. And I tried to look it up, and you got to remember, this is before Google, okay? And I'm in college, and we can't figure this out. And you notice after a while, the Teflon starts to chip off the pan. And not that you notice it in your food, that's where it's going.
Right.
But you notice that the pan is getting nicks and scratches in it, and that it's not as easy to wash, and those are some things. And so much later in life, I think right before I got married, I learned the answer to this question. And I can't spell the word, but the answer to the question is formaldehyde. So I'm going to butcher it.
Nice.
Yeah, there's no way that's right. Okay? Formaldehyde, of course, is a preservative they used to put in dead things,
Right.
so that they would last a long time to be dissected or whatever. It turns out that this guy, formaldehyde, is a really toxic carcinogen. Once again, probably not spelling that right. What's a carcinogen, Mr. Sadler?
That's a cancer-causing compound.
Excellent. And it actually, this is one of the worst things. They put these in cigarettes. Actually, they actually put carcinogens and specifically formaldehyde to preserve the flavor of the cigarette, if I read the ad correctly.
Mm-hmm.
And this was on my cookware. And as you're scraping that pan, trying to get that grilled cheese sandwich off the bottom of it, you're getting some of that Teflon on the bread, and that's what made that grilled cheese sandwich taste so
Yeah,
good, of
of
course,
course.
was the formaldehyde. So the no stick substance, Teflon, low coefficient of friction, highly toxic. Probably okay in the form of tape for like fitting a pipe. Probably okay for engine parts and some other things, but not something you want to be eating.
These Teflon coatings are actually going away. They're going to a more green coating. The only problem is they don't last as long as the
Right.
traditional.
There's and there were a lot of things in technology that evolve that we get away from that were really good but really toxic to people, like leaded gasoline was really awesome stuff until you get lead poisoning, and then it's not so awesome.
And they actually added the lead to gasoline to make the engine parts slide better.
That's right.
Right.
And now they haven't made leaded gasoline in 25 years, and they haven't found a suitable replacement.
Right.
Which is part of the reason why fuel costs are high, because they're doing research trying to figure out what's best. So that's enough about the wonders of technology and applications to people. So signing off, this is Mr. White.
And Mr. Sadler.